This is a talk on what to do in core sciences. I am sure you have a couple of courses in mathematics, physics and chemistry. Have you looked at the new AICTE curriculum? Huh? Have you tried to change?
We are going through a course by course restructuring curriculum.
Right. So, now if you are doing it and others who are not doing it, but may think of doing it in the future, what do you expect from a core course? First, I mean, I do go to interact with a lot of engineering faculty and they say कि science तो ठीक है, engineering पढ़ने आए हैं. So, why that attitude? And I hope through this lecture I will change that. But I just want to know why is that attitude? Is that, I mean, is a correct assessment?
Actually, what we found that the maths people teach transforms, they teach it with an example that is always going to be useful in our courses. We need to teach it again with our example.
Okay, so let's just keep writing it. So, why this? Okay. So, because I want to address these questions, chalk. पीला अच्छा दिख जाएगा मेरे ख्याल से. So, let's write this. So, instead of blaming only maths, I will just say examples not relevant. Is that a proper word? रख दो फिर कर लेंगे अभी जब लगाएंगे आराम से ही करेंगे. What else? Okay, so let me put it in a more positive way. Why do you want science to be taught or core courses to be taught? Huh? So let's write it here. Science courses many engineering. What else? Rules are general. Okay. What else? I am a very interactive kind of person. आप चुप हो जाओ मैं भी चुप हो जाऊंगा थोड़ी देर में चाय वाय पियेंगे चले जाएंगे कुछ तो बोलिए. Question is, so earlier I was saying that I have seen resistance among engineering faculty about science, and I will give you another reason for it when I looked into it why that happens. Then I said let me put it in a positive way, and positive way is why is science teaching maths, physics, chemistry, and we can even include humanities and social science. Why is that important? And we are trying to just list the reasons why you as science engineering faculty feel science should be taught or if should not be taught.
All of things actually have a role to play when you are engineering a product.
Say that again.
You cannot engineer a product in isolation. You actually need inputs from all of these areas.
So that it comes from forms the basis of many things and rules of science generic, right?
So whatever engineers produce, they should be useful to mankind.
Mm-hmm.
So we have the concept of humanistic engineering.
Humanistic engineering. So
We need all these social sciences.
okay, so social sciences, okay. For producing engineers who are connected socio-economic cultural needs of a society. Is that a proper statement? Is that what you wanted to say? Okay. Any other reasons that you can think of? So, on the negative side, a lot of faculties feel that whatever is taught is not relevant, right. On the positive side, it forms basis for many courses. Rules of science are generic and social sciences producing engineers who are connected to socio-economic cultural needs. Now, do you ever give this feedback to your science faculty? You do, and what do they say?
They stop teaching that part because they know that engineering students are already teaching them some other course. They just say we'll
So,
learn it in the course.
see, the dialogue is very important. So, I'll take it one by one. One thing that science or core courses also perform, and that I think you should convey to your science faculty, is that when a lot of students who have come, a majority of them are just past 12th and they have just crammed whatever has been taught, the scientific way of thinking, or what is called in general parlance scientific temperament, how you experiment, how you deduce, how you think about things, is not there, right. By the time they come to engineering courses, they are actually solving problems. Before that, one very important role that these courses play is that they develop a scientific way of thinking. And therefore, I think if you tell the science faculty or mathematics faculty in particular, when they do this epsilon, delta, limit and all that, and there is a tendency to say, "Arey chodo yaar, bore ho rahe hain," right? But that is not correct. It actually is a scientific way of thinking. It tells you how to approach a problem in a proper way. So, a mathematician teaches in a mathematics way is very important, because then you are actually developing a way of thinking which is going to be orthogonal to whatever way you are taught later, and in more different ways you think about things, better you are. More importantly, unless you know exactly how a theory can fail, and that is where all these theorems come in, right. You make a product, it does not work, right? What do you do? So, it is important to know, right, although you may forget the exact details, but important to know what this mathematics which is being taught, how it was developed, what are the lacunas, right, so that you can apply it properly. So, tell your faculty, keep teaching the way you are, do not stop it. If you are doing Fourier transform, right, which is used quite a lot in electrical engineering, or vibrations and heat and things like those, I would also like to know where it can fail, where the series can give me a problem, right. How many terms should I take? How do I make an error estimate, right? And that is something a mathematician can do in a much more fundamental way. Let him do it. How does it matter, right? The other thing is, what you should also be telling the faculty is, give them examples that can be covered in scientific course. You see, the thing is, it is very important to connect through different things. Now, you may do something in engineering courses, but it is important when somebody is learning a principle that he or she connect it with an application right there. That is where you can actually contribute to teaching of core courses. Give a feedback to your science faculty. Third reason, which I recently found out when I kind of pushed the principles and management of private colleges, is that साइंस फैकल्टी आके 2 कोर्स पढ़ाते हैं साल में, क्यों रखे हैं उनको? एडॉक पे लो, खत्म करो किस्सा, right? And that is something, therefore science is not taught well. I mean, basically people you hire are on ad hoc and they are incompetent. I mean, let me just put it so. So, I have written to one particular VC whom I am talking to, that you should also introduce MSc courses, so that you have permanent faculty. Most of the technical universities do not have science subjects as science granting degree, right? So, that is the logistic part. That apart, whatever you are doing, give a feedback, right. So, examples not relevant, hopefully I have addressed that, and if there are any comments or anything I can.
One thing I feel is that the students who are so-called writers who will go to engineering,
Yeah, so that premise is wrong. Let's throw it out right away.
That is wrong, but that is there. Let us accept the fact. So the students
No,
feel
what
that
accept what fact?
when students feel that when I am selected in engineering, I am above those who are not selected, and those who are not selected are studying BSc, for example, science, maths. So I am above those people. So it is very important for the engineering teachers of the engineering subjects also, to tell the importance of science subjects to their students. You know,
Very good point.
probably I am teaching you mechanics of solids, or I am teaching you thermodynamics, but physics is very important. Equally
Yes.
important, maybe more important.
Yeah, actually this is
Because
physics.
what I am teaching is fundamentals of science.
It is physics.
What I
Yeah.
am teaching is fundamentals of
Yes,
science.
yes,
So please be very attentive in the
yes.
science
A
subject.
very good point. So what you're saying is that the engineering students come to an engineering college with a chip on their shoulder,
Exactly.
right? And that has to be taken away. That अब तो हम तो इंजीनियर बनने जा रहे हैं, इसको ये सब क्या पढ़ेंगे जो लोग दूसरे पढ़ते हैं जो हमसे नीचे हैं.
जो हमसे नीचे वाले पढ़ रहे हैं वो हम
No,
लोग पढ़ें।
very important point. Very important point. Is that, so they have to be, again, as I was saying. So I was putting it in a nutshell, but you made it very nicely and elaborately. That scientific temperament, that they have to be told, look, whether you do engineering, whether you are a doctor, your way of thinking has to be scientific.
If a chemistry teacher tells the student that this chemistry is very important,
Yes.
that will not have so much impact. If a material science teacher tells that chemistry is very important, that will make a big impact.
Absolutely, absolutely. So maybe when the chemistry teacher teaches, connects,
Connect with the
and that is very important,
engineering.
right? So the students would feel, aha, this is so relevant to me, maybe I should learn it.
Right.
Any other point?
While teaching science subjects, I think we should, the theoretical aspects of science should cover the physical significance of the underlying theoretical principles and how it connects with technological aspects.
Absolutely. That point is very well made. What he says is, when I am teaching theory, and that is not just for engineering subjects, it is also whenever I am teaching science, people have to understand that it is relevant by looking at examples around us. And for engineers with that kind of chip on the shoulder, it again becomes more, they are told, look, what you are actually doing is physics, it is just that you are applying it now, right. So, it is a very good point, and I hope I will show through examples that how we do it here, okay, how I do it in my class. Okay. So, the only thing is, it requires little effort, and I think the effort has to be a teamwork. You take a lot of initiative yourself. If you have it, you can do it yourself. Otherwise, you also gather a team of like-minded people, talk over a cup of tea or something, and then people may say, engineering faculty may say, and I will show you examples where some engineering faculty have actually told me what I was thinking about. So, I got enriched. He is my PhD student. Yesterday I was talking to him about something, and he gave me a problem. So, talking to people, science is an activity where you have to talk science, engineering, technology, everything, right. So that talking helps. So, like the point you are making, maybe if this is discussed among faculty from different departments, it suddenly occurs to everyone that, look, this is how we should be doing it. So, scientific temperament is one thing. Other thing is that in today's world, right, I don't remember the person who said it, but he is a very senior person in some corporate world, some technology company, maybe IBM or Hewlett Packard or something, and he was asked, what is important in today's world, and he said, earlier people who were rich actually stocked knowledge, right, they gathered knowledge and kept it with them. Whoever kept that knowledge, right, it was with them, and they could use it, they could make money on it. So, that stock of knowledge was actually the money, and that in recent times with the internet and the cloud and everything has been replaced by flow of knowledge. It is not important to stock it. What is important? Knowledge is flowing. You want to know something, boom, Google it, do it, and you find 50 things about it. What is important is flow of knowledge, and you got to be in that flow. You got to catch the flow, right, and you got to contribute to the flow. And if there is so much going on, we will be doing a disservice to the future generation, to the engineers, the scientists we are training, if we do not give them an idea of catching this flow. It is not like I will go to some boss, intern with him or her for some time and come back richer. That does not happen anymore. What happens is flowing, and you got to catch it, right. And not only you catch it, you also contribute, because if you are only in the catching business, after some time you will be left behind, right. And for that to happen, you have to have a very wide background. If I say, no, I do only data structures, that is it, I am stuck there. Somebody with that data structure is doing something else, I got to be able to catch it, get into the flow. So, I have to know all the other relevant things, and therefore, this broad knowledge becomes very important. And if this broad knowledge becomes important, I have to prepare the students for this broad knowledge, and core courses put the foundation, they provide the foundation. So, actually we in India, and pardon me if some of you are from private colleges, but the management of private colleges has this view, हथौड़ा चलाना सिखा दो हमारा engineer बन गया. But that is not true anymore, right. So, you have to be able to catch that knowledge and contribute to it, then you are participating. That is very important. So, it is a paradigm shift, and that paradigm shift is we have to be aware of it, and therefore, I have to teach, I have to train my young people, so that they are in this new paradigm. They are able to catch knowledge, they are able to understand the proper language, they are able to connect it with other things that are going on, and then they are also able to contribute. So, projects, research papers, they also become important. Everybody, if they want to contribute to this flow, have to be able to produce something, no matter which way, but everything you produce, everything cannot be equally relevant, but you have to be producing and something will be relevant. So, at least you have to be thinking about, you have to be sensitized along those lines, all right. So, this is the foundation that core courses provide. Earlier, there was a big distinction, right. Cauchy was doing his theorem, Gauss was doing his theorem and all that, and engineers were going with their hammers and tongs and everything and making bridges and everything. Slowly they started coming together, right. Can you imagine finite element methods without Gauss? No, you have to know it, right. So, it is very important. Can you think of a civil engineer who is doing something on a river and does not know about environment, because the moment you disturb the river bed, right, there is a lot of marine life under the river bed, you have to know about it. Otherwise, there will be Greenpeace people, flag wearing people, what are you doing, activists will be coming in. So, that humanities part becomes important, environment becomes important, sensitivity of people becomes important, and the background for all this is given by your initial core courses, because later students start doing their the courses in engineering and start doing their projects, but by the time they do it, if they have been sensitized enough, right, that how you connect different things, then they will do it, you will produce a better engineer. Finally, a very important aspect of all this is that whenever students come to engineering colleges, and whenever you talk to people who are funding engineering colleges, whether it is the government or whether it is the private enterprises, whether it is a private trust, they always emphasize that we are going to produce engineers who get good jobs, right, who are in demand in the job market, and they will put placement figures on the display. What we forget is a very important aspect, and that important aspect is not only should I be preparing people for getting jobs, it is very important, a lot of people want jobs. I should also be preparing people who can come back to the system and produce more such like this. You see what I am saying? So, I got to be able to produce people who will go for higher studies, who will go become teachers, who will become faculty members, right. And for that to happen, I do not know if a person who is graduating in civil engineering, tomorrow he may be doing fluids, right. A person who is graduating in computer science, tomorrow may be doing computational biology, right. If all that and may come back, because remember, person who has come out of 12th has not been exposed to many things. It is our duty to expose them to many different fields, and then maybe the interest level may go into something else. Initially people, you talk to people who come to engineering, they say, oh, we want to do computer science. Slowly, as they get more and more exposed, they start doing other things. So, I should be able to actually feed into their curiosity, their way of learning, right, and also prepare them that if they want to go to higher studies, they can go to different fields and come back as faculty members. Otherwise, our kinds will die down after some time. We will become, teachers will become extinct like tigers, and then you have nobody to produce. So, it is important that we also teach things that make them relevant of, make them aware of many different areas, and they start connecting it, and that is where again core courses play a very important role, because in core I am covering my life sciences, humanities, physics, chemistry, maths, right, and now IIT Kanpur also does earth sciences. We also do many different things. All this is very important, because then the kid is exposed to many things, would start connecting, and later may decide that I want to go for higher studies. If at least 10% of our own students do not go for higher studies, we are doing something wrong, and you have to prepare students for that. Otherwise, with time the number of people coming back to this line would be going down. Okay. So, that hopefully covers what all were you saying, right. Any other comments or anything on this discussion?
So, yesterday we were talking about FIAM and MOOCs and flipped classrooms and all so many things. Don't you think that all these things will defeat this purpose written in the rightmost column?
The humanities, yeah,
Economic, cultural needs of the society and the teamwork.
certainly. So,
Interactions and all these things.
okay,
Is
so
that not going to defeat this?
no, okay,
What we get in a classroom, 30, 40, 60 students sitting in a classroom,
yes,
listening to a teacher, interacting with each other and so many things. Is that not going to defeat?
yeah. So, I will answer that question. So, I faced this problem. There was a student, very bright student, his all India rank was in top 50s, and he was doing physics, and he did 3 courses with me, and after the 3rd course he wrote me a mail, and he said that, sir, I am seeing that after 3 years I used to be a very intuitive thinker. I could think about things in a very intuitive manner, and what I am finding is I am becoming very mechanical. I am taking rules, applying them. And it is a very sincere mail. It may be somewhere in my email. It took me about 4 or 5 days before I could reply to him, because he raised very important question. So, finally, what I wrote to him was this. I said, look, any mass education system by definition has to hit the average person. If you are going for mass education, you have to apply it to many people, right. And but so that is system has to be like that. However, if you feel that you can think about something intuitive, don't give it up and talk to people, talk to your teacher later. If the teacher is sincere, if the college is good, IIT, a lot of faculty interact, they will then talk separately to you, right. So, now when we are trying to address, we are trying to produce whatever 50 lakh engineers a year or something, mass education, we cannot do this, right. But what we have to be aware of is there are people who want this personal attention, who are different kind, who are above average, and that is where a teacher has to be very attentive to that. So, it does not defeat the purpose of mass education, but it does defeat the purpose of getting a percentage of population who are thinkers at a higher level. So, the fact that you are even raising this question is that you have done a good HSS course. So, the course that way is important. So, see, the idea is that when a student passes through a college after 4 years, he or she does not remember whether you derived something correctly, whether you did a problem wrong or something. What the person leaves with is an influence you leave on the person. They see your way of approaching things. You actually sensitize them about things. And as long as you are sensitizing, you are doing your job. Sensitizing through examples, it does not mean that I do all the problems wrong all the time, but I am sensitizing about these things precisely what you are talking about. So, one can say I am doing MOOC, but at the same time if you have any questions, I will try to be interactive, right. So, even raising this question itself is very important. So, earlier people were going gaga about MOOC, right. I have also done a couple of courses, 3 courses on MOOC. Then once you do it, you realize it is not as the same. Then you add a forum, where you spend hour and a half every morning to answer questions. Then you also add something else. It is not a substitute for class for sure. So, then you have to tell yourself, what do I convey to the students, that if you want to do this. So, what I try to do is give them a lot of material to read. Either I upload it, right. So, your question is very relevant and one has to keep thinking about it. At the same time, it has to be balanced with the other need that I want to reach out to as many people as possible. Now, think of a person in Arunachal Pradesh where I do not even have a teacher. How do I reach him? MOOC is an answer, but then I have to be very, very sensitive to the fact that that person has nobody else to go to. So, how do I address that? So, your question is very relevant and one has to keep thinking about it.
These technologies are only complementing the classroom teaching.
They should be actually complementary to the classroom.
Though there is no question about it. So, not just this technology, any technology, whether it is your mobile, whether it is a phone, whether it is what I call in the military parlance is a force multiplier. To multiply a force has to be there, and that is the classroom. Absolutely right. But it does. So, I am not going against what you are saying. It does help sometime, as I gave the example of Arunachal Pradesh or some place which is absolutely remote, there is nobody, it can reach there. So, there is something, but certainly it does not, in ideal situation it should not be replacing classroom, but supplementing it. Yeah, the point is well made. Any other comments or discussion? मेरे को थोड़ा जुकाम हो गया था, मैं सुन जरा कम रहा हूँ, तो इसलिए जरा ऊंचा बोलना पड़ेगा आपको.
किसान जब फसल उगाता है उसमें से बेस्ट पार्ट वो अगले साल की बीज के लिए रखता है. The one which is not so good in reproducing is being sold.
The one, let's not say not so good, one which is average.
Average is being sold for money, but the best thing is kept to himself for reproducing in the next for the next year. That doesn't happen with our product.
So, very good example. That's what I was saying. 10% if they should come back to higher studies.
Not top 10 is coming back to us. Second is a driver who can kill maximum 2% if he is not trained. He is supposed to train and pass. After that, he is allowed to go on the roads. A teacher who is supposed to be nation builder. None of them is given any proper training of teaching. We are graduates. We might have studied some course, but we were never trained for teaching. But we are teaching.
Okay, so that's a
Emphasis, I don't understand why nobody is giving on teaching.
okay. No, teaching is important. I'll tell you. So, the second, I'll answer your second question first. Any academic institution is supposed to be free thinking. So, I need not give formal training like high school teachers, because you are supposed to be thinkers, right. You find your own way. I had raised the same question to my postdoc advisor when I was doing postdoc, and he said, as a teacher, as a faculty member, as a thinking person, you are supposed to find your own way, and that brings variety to teaching. Imagine if all of us were trained and told, you go to class, say hello, good morning, how are you, and then you write something on the board, make some phool patti on the side, it will be very boring, right. After some time everybody would walk out or would go to sleep. So, each one of us brings individuality. So, we may be given a general broad outline which we learn from our teachers, right, but then it is up to you how you make it, right. You interact, you take feedback, otherwise you will be just typecast. So, there is a good reason why it is not done. What should be done is regular workshops and exchange of ideas how you teach in the class, right. That is what we are here for. So, that should be done, but formal teacher training.
No, not formal. What I'm saying is we are supposed to go through the orientation refresher courses after confirmation in the job. So that is after 1 year or 2 years, and people normally do it at the place where it is required for promotion after 5 years. So the first kind of such interaction happens after 5 years of job. So all the damage to be done has already been done. So after 5 years of teaching, normally people don't
Right.
tend to change their ways.
That is true. Somebody asked Feynman once, if you are so smart, why don't you solve world's problems? I am not so smart, I can't answer that question. And you know the answer, I also know the answer. So, now let me go back to all these points, and I will just, through examples, I just want to show you how you can make science core courses, how you impart scientific temperament, at the same time keep connecting with things, right. It does require a lot of effort though, effort, teamwork, and talking to a lot of people. Okay. So, let me just start. Okay. So, first is let us do some mechanics, all right. Now, mechanically, I mean all of you have gone through core courses, so you know about angular momentum, right. What is angular momentum? It has something to do with the rotation, right. And when you rotate, right, where do you think this all this rotational dynamics and all that comes into play? All mechanical devices, right. You talk about planes, you talk about helicopters, you talk about rolling of things, it comes into play, all right. So, let me start with one example. Let me see what sequence I have it in. Okay, let us start with this first. A magnet fall, अरे इसका वो भी लगा देना internet. Or let me start with a simple example from electromagnetic theory, and this is, if I take you have all heard of Lenz's law, Faraday's law, right. What it says is that it opposes motion. Can you think of where it is used? In induction motors. Induction motor mein to Faraday's law, not Lenz's. Lenz's is the other way, that it opposes motion. Transformer also is not Lenz's law so much. Huh? Right. Lenz's law tells you that energy conservation, you have to supply energy to take it out, right. That's So how does it work on Lenz's law? I thought it was Faraday's law.
Both induction motor and transformer says that the current flows to oppose the cause which is making it flow.
Achha, that way, okay. I thought it was just you produce an EMF and it flows.
It produces magnetic force to oppose the force which is making the current to flow. That is Lenz.
Generated EMF generates a torque.
But induction, so let me just argue a bit. Induction motor means I have to produce an EMF and a current, that just gives me heat, right?
It is actually the
No.
It is
It's a-
actually the EMF given is going to generate a rotating magnet. It induces EMF in the rotor conductor. Now the movement of the rotor conductor will be such that this EMF is not going to get produced. The direction of the rotor is generated.
Okay. So, but I thought that was Faraday's law. No, after that, induction is Faraday's, and after that the opposition.
The
Okay.
direction of motion is
Okay. So, I'll show you this, and then I'll show you exactly an example like this. Okay. So, I need some volunteers, right, and तो आपको इंडक्शन ही मोटर दिखा देते हैं. आइए, कुछ लोग आइए फिर. Just come over. मैं आपको मारने नहीं आया हूँ, वो करना होगा तो ये काफ़ी है. ढाई मन का हाथ काफ़ी है मेरा. ये इसमें what I like you to do is somebody drop the chalk and start counting. आप ही काउंट करिएगा, सबको दिखाइए और कितना टाइम में आ रही है. जोर से काउंट करिए.
1 2 नहीं 1 2 3 4 ऐसे.
हाँ, कितने टाइम में नीचे आ रहा है.
1 2 3 से पहले आ जाता.
ठीक है, ये आप हाँ काफ़ी तेज़ी से बोलो, इसी स्पीड से बोलिएगा, नहीं तो मैं उल्लू बन जाऊँगा.
नहीं सर.
मैकेनिकल इंजीनियर से मेरे को भी डर लगता है, उनका हथौड़े बहुत होते हैं, ठोक ठाक दें तो गड़बड़ हो जाएगी.
So you are changing mass now.
No, I'm going to now you drop this and count.
1 2 3 4 ज़्यादा हो गया.
हाँ करिए.
1 2 3 4 5 6
6, right?
2 तक आ रहा. 1 2 3 4 5 6
Okay, now let's
7 तक आ रहा.
now do it with this.
Magnetic. 1 2 3 4 5 6 7 8 9 10 11.
Does everybody
1
see
2 3
it?
4 5 6 7 8 9 10 11 12.
12. Now what I'm going to do is change this. Take this. Chalk. वो इतना ही आएगा 1 2 3.
1 2 3 4 5
आराम से करिए.
1 2 3 4 5 6.
Okay. Now this.
1 2 3 ये जल्दी आया.
ठीक है, वो कुछ गड़बड़ कर रहा है.
वो अटक रही होगी सब
हाँ,
बड़ी
आप
होगी.
करिए.
1 2 3 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 20. 1 2 3 4 20 21 22 23.
Okay. Now this is a, So, these are magnets that I am putting in. Okay. So, no. So, this is a big magnet and do it with a small magnet, they will come down slightly faster. 13. So, 3, 13, 20.
20. That is the difference.
Now, what is the difference between the two?
That is
This one and this one.
aluminum is a conductor, copper is a better conductor.
Better conductor. So, more current, more opposition. Anybody else would like to come and do it?
ये आप लोगों के लिए जो इलेक्ट्रिकल वालों के लिए बहुत बढ़िया वो है सर एग्जांपल.
मैकेनिकल के लिए भी अच्छा मैं दिखाऊंगा आपको. Okay, so what we see, the thing is, ये अब हम लोग जैसे हिचकते हैं आने में, अपने दिल में जो बच्चा है उसको आने दीजिए, खेलिए थोड़ा चीज़ों से, क्या फ़र्क पड़ता है उससे. If you play well with it, you will make your students play well with it. होता क्या है, बच्चों ने ऐसी चीज़ें क्या कर रहे हैं, but I'll show you how this can be useful. ठीक है? So this is Lenz's law. What it does, it tells you if a magnet is falling through a metallic tube, right? If a magnet is falling through a metallic tube, it slows down, it opposes the motion. Okay, so remember what is there. There is a magnet in this and there is a metallic tube. Can I use it somewhere? Can I use this slowing down of magnet somewhere? And I'll show you an example. Okay, and that should make you happy, mechanical or electrical engineer both. And the moment you tell this to the students, they say, aha, you know, why I was not thinking of this. Let me just show it to you anyway. On this, the sound is not that important. This is a car, Audi car. Even the Cadillac that President of the United States rides in has the same suspension. You see, there is this shock absorbers, you see, right? These shock absorbers are in a ferrofluid. Ferrofluid is a fluid where these particles that can get magnetized are there. So, it is like this metallic tube, and when the current is going through them, they make a magnet, right? And then that opposes the motion. So, they become fantastic shock absorbers. That's right.
Can we call this an electromagnetic shock?
It is. That's why he says magnetic ride. These are electromagnetic shock absorbers with ferrofluid in, but their response time is much faster. The damping is much better, right? Wear tear is hardly any. There you go. And this is the best cars in the world have this. This is Audi, Cadillac, as I said, President of the United States, he has it. All the good cars have it. So, you write magnetic, electromagnetic shock absorbers in car and you will find a lot of these things. अब ये देखिए आप अभी power off है, ferrofluid काफ़ी चल रहा है ऊपर नीचे जब shock आ रहा है, ठीक है? The moment I put the power on, now you see it hardly moves, right? I have given you an example when I teach Faraday's or Lenz's law. By giving this example, I immediately connect with the students who want to do electrical engineering or mechanical engineering or automobile engineering. Okay? So, the questions that somebody earlier gave that examples are not relevant, I can do all the theory, I can write d phi dt, minus sign, this, that, curl, everything, and then I give this example. दूसरा तो नहीं आ गया, हाँ इसको छोड़ दो. Okay, now I'll show you. I'm going to just say that since you asked, magnetic shock absorber. The slides, let's see, now I'll go to YouTube video. आवाज़ क्यों नहीं आ रही है?
An electromagnetic active suspension system is being developed by the departments of Electrical and Mechanical Engineering at Eindhoven University of Technology.
So right now he has said the right word, electrical and mechanical engineering.
My name is Mark Gijzen and I'm a PhD student at the Eindhoven University of Technology. The project is in cooperation and funded by SKF Automotive Development Center in the UK. And the idea of the project was to develop an electromagnetic active suspension system for passenger cars.
Electromagnetic solutions are more efficient than commercial hydraulic systems.
That should answer your question. Hydraulic system, they are more efficient.
Resulting in an increased performance in both comfort and handling. Furthermore, it's even possible to regenerate energy from the road vibrations. GTD prototyping facilities is a separate department within TUE, which takes care of the technical support of education and research at TUE. GTD design equipment for experimental research, offer specialist support, and create prototypes. The active suspension is being developed with the help of GTD prototyping facilities. The system consists of a mechanical spring in parallel with a linear tubular magnet actuator. The mechanical spring supports the body of the car, while the actuator can provide direct drive forces of nominal 1 kilonewton in the vertical direction. Additionally, electromagnetic passive damping is integrated in the actuator to make the total system fail-safe. In the case of a power breakdown, the system still behaves as a passive BMW suspension system. This topology is patented by SKF. The quarter car test setup allows for controlled testing of the behavior of the active suspension system. It stimulates one corner of the car. Road vibrations are applied from the bottom, and the wheel is mimicked by a mechanical spring and a mass. The large red block on the top represents the quarter body mass. By means of proper control, the body acceleration is minimized by the active suspension, indicating the improvement in comfort. The suspension system is designed to fit underneath a BMW 530i. The video shows the dynamic capabilities of the actuator. Various modes can be activated. For example, the vertical body resonance, the longitudinal body resonance.
You see the wheels are hardly moving. So if the other way, wheels move, the body doesn't move.
Bandwidth, it can even function as a speaker. On-road tests will follow shortly.
So you see the point that you are making. You can make class exciting, you can make science relevant, you can see, she even talks about research and development taking place. So it is combining all these science principles.
Hello everyone and welcome. In this video I'm going to be explaining magnetic ride suspensions. Now the purpose of magnetic ride suspensions is to be able to actively control the damping force of your
Alright, so you can see right away that you can make class interesting with that. Okay? Just a simple demonstration and exactly the same thing being done in a car. Okay? Yes. Okay. Now I'll go to something else. All right. And let me see what do I have here. Okay. I'll show this also on YouTube, but before that I need to show this to you. I have this track. All right. Let's put this up. इसमें ही लगाते हैं. And you notice that whatever I showed you is not very expensive. These magnets are available for 30-40 rupees in the market, and this tube you can make in your workshop. So it's being.
Effect of thickness of tube?
Yes, of course. After certain thickness it doesn't matter, but till certain thickness it does matter. Okay, because if you make it very thin, resistance is high. If you make it wide, current actually goes up to some maybe 2 or 3 millimeters. After that, it doesn't matter. Okay, but the point is that if you are trying to be innovative, things are cheap, right? And you can just make them and show it to the students. And see, it is all that BMW model is a top model. All other cars where it's used because it's expensive to make. All right. Now I'm going to show this to you. लगवाओ यार जरा सा इसको इधर से शुरू करते हैं. इसको सबसे एंड में वो वाला, ये बीच में है शायद, ये बीच में, हाँ ये वाला बीच में. ये वो वाला होगा बीच में
So इसका बीच वाला
बीच वाला वो तो नहीं है जा रहा है again I need people to have fun with it okay और पीछे और नीचे हो जाता है और रुक जाओ हाँ ये हो गया काम ठीक okay so I just want to show it to you what it is it's a track like this you see it turns both ways it is like this right and what I want people to come over here somebody should come as many as would like to play with it. I'll give you these 4 cylinders which are to be rolled on this.
They're not cylinders actually.
Yeah, whatever. It's 4 rollers.
4 rollers, yeah.
Okay. Now wait. And I want you to show it to the people and then guess which one would go all the way negotiating all curves if it goes slow enough.
सबसे पहले cylindrical को करो.
उधर से लुढ़काना होगा हल्के से दीजिएगा बहुत तेज करेंगे तो लुढ़क जाएगा मामला and let people also guess थोड़ा मजा करिए एक बार और ट्राई कर लीजिए ठीक है ये गया और दूसरा ट्राई करिए आप भी बताइए कौन सा जाएगा ये देखिए अब दूसरा ये वाला से ट्राई कर रहे हैं ये देखिए ठीक है जरा पीछे भी हो जाए लोगों को देखने दीजिए
This one has a larger diameter in the middle and less diameter at the
maybe it was a fluke हाँ
It was not.
वो भी ट्राई कर लीजिए हो सकता है ये उल्लू बनाने को है इसमें लगता है इधर उधर दोनों तरफ हो जाए तो लग जाता है द मिडिल पोर्शन डजंट रियली मैटर ठीक है एनीबडी एल्स वुड लाइक टू प्ले विद देम ओके सो नाउ यू कैन शो दिस डेमोन्स्ट्रेशन दिस I'm going to come to that okay now this is very relevant अब मैं नेता होता अभी तक तालियां बज गई होती उनके लिए तो thing is when I teach this is at the beginning really at the beginning of rotational mechanics okay and when I teach this I always show this demonstration and the whole thing is very simple you see and this probably somebody discovered it by accident which is called serendipity okay this one if it is going like this suppose the track curves like this okay suppose the track ऐसे चले गया so what you will notice कि ऐसे जाके अब ये larger portion the bigger radius comes into contact and bigger radius means
larger linear distance.
Yes more speed it turns this way if it is turning this way here it comes it turns this way so it can negotiate both sides. You can also then apply dynamics. You can also show that the normal reactions and the torque produced by them are also right. Normal reaction is larger on one side, it gives you the centripetal force and the corresponding torque also makes it rotate like this. So, you can go, but the first simple explanation is this okay? And therefore, I do not need a differential if I use this. Cars have a differential. When I turn a car right or a truck if you in trucks it is very easily seen. There is a huge thing in the middle, you know, the axis in the back side and that is a differential gear. When the truck turns, it makes the outer wheel go faster, right, but trains do not have a differential, trains use this principle. okay, because trains I cannot maintain so many differentials, right, and it's heavy, right. So, this is the moment I show this, I have given you all the demonstrations, आपने उन सब की मजाक भी बना दी, सब कुछ कर दिया, it's very relevant. I will show you that. This is the title, how train turns. And this is basic physics, first course in physics, that is where you say it, but you make them realize how important it is. ये देखिए वही जो सिलेंडर है बीच का हिस्सा हटा दिया है उसका, इज द सेम सिलेंडर विच इज टेपरिंग डाउन ऑन द आउटसाइड. Now you see that which I was explaining, the larger radius has come into the contact. वो तो होगा ही जब उसका इतना ज़्यादा स्पीड होगा, and if you have to create more speed differential, if the tapering is not much, then there will be a problem, and I'll show that to you. That also, your question is very relevant. हाँ, नो फ्लैंज से कुछ, फ्लैंज से वो काम नहीं होता है, फ्लैंज थोड़ा ज़्यादा रेडियस देता है, बट मेन टर्निंग इससे ही आती है. साइड में फ्लैंज होता है थोड़ा सा ऐसे करके, हाँ, वो स्लाइडिंग ओवर, बट इट डजंट हेल्प इन टर्निंग. मैंने इसके चक्करों में आरडीओ से वो पढ़ डाले क्लास में पढ़ाने से पहले, उसमें सब ये फंडे क्लियर हुए. अब ये देखिए बताएगा उसका. सो दिस बिकम्स अ वेरी गुड वीडियो, राइट, बट डेमो immediately explains you the moment you teach V equals omega r, you do this. ये इफेक्ट हो रहा है आपने जो पूछा था ना, effectively is increasing. So all you do is you take the cylinder for the wheels, it doesn't matter what's in the middle, you just cut it, it's just tapering down. और ये उल्लू बनाने के लिए, बिकॉज इसमें लोग ये समझते हैं कि इधर को जाएगा ये रोक लेगा, इधर को जाएगा ये रोक लेगा, काम चल जाएगा. A lot of people say that this will go through. वो फ्लैंज है. वो फ्लैंज थोड़ा सा और ज़्यादा कर देता है कर्व. Okay, so I'll show you. Somebody asked whether high speed what happens. It's at high speed. It's not just that the slope matters. There's something else which comes through, and so you have to experiment. So engineers, you again tell, look, I mean, if you are doing things, you have to start experimenting. So let me see if that is there. ये देखिए,
into a bullet train. It starts with the simplest thing.
पावर ऑन है स्पीकर की. सुनाई पड़ रहा है आपको?
The one place where a wheeled vehicle would have is a straight piece of track like this. Where you've got wheels, rails,
वीडियो का फुल करा हुआ है.
what could possibly go wrong? In fact, everything can go wrong if the wheels are the wrong shape. I mean, it's still round. Round is good in a wheel, but it's the part that touches the track here that makes contact. That is absolutely critical. Without the help of a medieval clock,
इस पे
a
नीचे है.
high-speed train would simply throw itself off the rails.
शुरू से कर देता हूँ ये लीजिए.
Train into a bullet train.
ये आपने स्पीड का क्वेश्चन पूछा था ना किसी से, आप क्लास में पढ़ाओगे ये क्वेश्चन आएगा. यू कैन शो दिस.
The shape of the wheels. You would think the one place where a wheeled vehicle would have no problems at all is a straight piece of track like this. I mean, you've got wheels, rails, no bends. What could possibly go wrong? In fact, everything can go wrong if the wheels are the wrong shape. I mean, it's still round. Round is good in a wheel, but it's the part that touches the track here that makes contact. That is absolutely critical. Without the help of a medieval clock, a high-speed train would simply throw itself off the rails. No need to take my word for it, because I've brought my very own carriage to the Hammond Railway's proving ground for its inaugural journey to test its wheels. It's not a grand design, it doesn't even have its own power, but that doesn't matter, because I've got a powerful winch to drag it along this dead straight piece of track at speeds up to 50 miles an hour. Unfortunately, Hammond Railways don't stretch to the basic amenities like seats. That's one of the reasons why I won't be riding on my carriage. The other reason is, well, it doesn't have any brakes. I did say it was basic. It'll be brought to a complete and probably quite sudden halt by that barrier down there. On the plus side, this does have everything we need to show just what high-speed train engineers are up against. Namely, we've fitted it with these train-style wheels.
You see, these wheels are highly tapered.
But just like real train wheels, they're conical, angled where they rest on the track. They might look pretty odd, but according to Paul Allen, an expert in wheel dynamics, they'll show clearly what happens to real trains travelling at speed. Finally, Hammond Rail is offering a feature never before seen on trains: basketballs on poles. They'll show how the carriage moves. He's revving his V8 muscle car from 1970s. There he goes. As it speeds down the track at about 40 miles an hour, the carriage starts rocking from side to side. It's called hunting oscillation.
Hunting oscillation.
See, is that why the top of these posts are moving side to side?
Yeah, you can see it hunting a bit now.
That's not gone at all well for it, has it? That's a bad thing. The kind of thing you need to avoid in a
So you see, showed a demonstration, showed how railway should turn, but then you also showed if you want to design a high speed train, these new things come in called the hunting oscillations. With one demonstration with V equals omega r, which every 12th grader student knows, I made 3 points. Not only I made 3 points, I have kept you engaged, right. So, I have immediately connected, and that is the point.
That's a very big challenge for the teachers in the classroom now,
You have to work hard for it.
to keep the students engaged in the class.
So, you have to keep, so those are the points that somebody is making, and I hope I am answering those questions through these, that you can make things relevant, you can connect with technology. You also show right away that whatever formulas they are learning in their NCERT book or the first year mechanics book or electromagnetic book are highly relevant to design a proper system. Now, you see, and final point is in this you also show the
I have a question regarding this.
yes, I am not an expert on railways, by the way.
You started out with discussing the formula V equals to omega r, and then you demonstrated something where
hunting oscillation came in.
Yes.
Now, how is that relevant with that formula or basic?
Very good question. So, V equals omega r tells you if I have these train wheels which are tapered down, that works, right. Then I say now, and then somebody asked, how about what happens when you go to high speed, does it work at every speed? So, I say now let us experiment. I have the wheels which are still tapering down, but the moment you hit the high speed, it starts going back and hunting oscillations. So, I make a point, if you want to design a high speed train, do more experimentation. Now, you have to do something more than just designing your wheel like this. You are making a point to the students, you have to keep thinking.
When the complexity
And the moment you make a problem, yeah.
What you are justifying is that
I am not justifying.
more to the there's something.
I am making a core course relevant to an engineer. That is what I am doing. I am not justifying anything. All I am saying is these things you have to learn, and you have to learn to experiment. You have to learn to ask questions.
You are actually sensitizing us. Now, if you have that doubt, you will go and you will try to clear it up. So that's why you will not mug the subject. You will try to find out new things. That's what he is saying. That
I am connecting.
sensitizing you.
The moment I taught V equals omega r, I connected with the, and then you see that this is the problem he started with. In fact, if you see the later portion, that should also answer your question. So, he has shown hunting oscillations, right, and
Rail train. And this isn't just a problem for Hammond Rail.
so I have also made it relevant that he initially showed these conical shaped wheel, that they are enough for a train to turn. Then at higher speed doesn't work because something new comes in. So, you need to learn more physics. I am making it relevant.
Derailed on straight track, and the repeated sideways movement can also change wheels. So they don't seem like such a good idea. Why aren't they flat?
Now, you see he explains it again. So, whatever point I have made, he is going to make it again. See, one thing in students you have to do is keep repeating yourself, and if you keep repeating yourself, you become very boring. So, you do make a point, show it, and then show it through other things. Simple चीज़ है. मैं ही बोलता रहूँगा, आप बोर हो जाओगे, थोड़ी देर में जाओगे, भाई साहब क्या बोल रहे हो आप?
Flanges are metal lips that sit down the side of the tracks.
We can put flanges on the wheels, but the trouble is then the wheels will be guided around the curve purely on these flanges, and we'll wear them out, and we'll wear the sides of the rails out, so they'll all be wrecked
Very quickly.
very quickly, yes.
So it's back to those conical wheels.
You see, so flanges is not the answer. Somebody was saying flanges.
Well, if we put some cone angles, then we might be able to get this to go around the curve.
You can cause the damage to the railway track.
Okay.
So, that's the point he is making. He is a railway research engineer.
And it's just,
This is what I showed you.
well, it works. That's just its shape. They're sending it round.
And by the way, if you thought I made this demonstration after seeing these videos, no. I saw it in a museum in Jaipur. And then it became relevant, and then I met a railway engineer, he said there is no differential, so I connected. These I discovered after making this.
Because conical wheels can effectively change size, they can make trains unstable, even on straight track, causing that hunting oscillation we saw, especially at
Okay, so to answer your question now, you see he is explaining, even this may cause trouble. So you are inducing students to think more and more. They should not think, balle balle ho gaya kaam yaar. Finally, my job is to make them think. That's what I said in the beginning. I want those 10% students who are very good to come back to the system, go for higher studies. This is what induces it. Right? Only teacher talking becomes very boring. So you bring different things. Anyway, rest you can see if you want to, right? So I'll stop it here.
is precision machined to the perfect angle.
So with internet, as I said earlier, flow of knowledge. There's so much available. Or you are limited by your own thinking, by your own amount of effort you can put in. Rest is available. There's a lot of flow. All right. Now, आपको नींद आ रही, चाय मंगवाएं? आपको yawning भी होने लगे, नींद आ रही है. अच्छा, अब इसके बाद जो है, let's see. Now this is something, the demo I showed you, Faraday's law I have shown, gyroscopic motion. Now This can be made very easily even in the class. What you do is take 2 cups, जो चाय पीने का कप आते हैं ना वो प्लास्टिक के, चिपका दो आप उल्टा करके, ऐसे हो जाएगा वो कॉनिकल. 2 पाइप लो, चला दो, हो गया काम. You don't have to do all that.
Existing trains in India, almost in 90 to 100% of the trains, we observe that hunting oscillation or lateral oscillation when the train moves on the track.
No, वो नहीं, वो जहाँ पर ट्रैक चेंज होता है वहाँ पे आते हैं खाली.
नहीं,
सीधे में भी आते हैं.
हर समय, sir, you can feel when you are sitting within the train. So this kind of lateral movement is there, which is not there in
Foreign trains.
metro or maybe the trains abroad. So
पर hunting से तो unstable हो जाता है. Hunting is actually stable. So it's not hunting, is something else.
that might be a cause of so much of
Traffic.
accidents which are taking
Maybe. So इसी
कह रहे ना सर, वो जो सेल्फ अलाइनिंग होता है, एक बार जब आप स्ट्रेट लाइन में भी जा रहे हैं, even though you
Even
are
in
moving in
straight
a
line,
straight line,
you feel the lateral movement.
this because it is coined at an angle, it moves around like this, and this one goes at a lower diameter and this at higher.
So maybe that's
And
what
it
gives
comes
the.
down at lower diameter. So this moves always like this.
So maybe that's what
You
gives
have-
rise to the oscillation.
You feel that lateral oscillations at the end of the bogies.
हाँ तो हो सकता है वही डिजाइन तो डिजाइन बेटर कर सकें कुछ करें. Anyway, I mean if you are raising questions, like this, good. The class also people will raise these questions. That's the whole idea, right? Now you can give through all this. I also wanted to create 2 projects. So I gave these projects to the students. Same thing would happen in a rickshaw. When rickshaw turns, rickshaw cannot afford a differential gear. It will become too expensive. What do? So either when you turn, either the wheels they skid, and therefore wear is much more. Another solution which people came up with was make one wheel free, right? But making one wheel free makes a rickshaw unstable. It topples, right? So you can write here a socially relevant project for BTech students, right? Similarly, that the other lenses law, a relevant project for students, make a shock absorber which is electromagnetic, right? These are things which are available. You are limited by your own thinking, your own how much effort you put in. Okay. So I hope the points that were being made earlier, I am making them clear how you can actually do it and why core courses are important, how you should conduct them. You don't conduct them just by going and writing from book. And this is a feedback you have to give to, rather than criticizing your science faculty. You say, look, this is what I found, can you explain this in the class? And this I did not learn just like that. I talked to people in another department and they taught me. Particularly the next example I am going to show you was, I was showing this demonstration in the class, and then I read somewhere about helicopter. I went to the person who is a helicopter expert, who is now retired. He taught me a lot of things about it. So this going back and forth and talking to people helps, right? So let me just show this to you. So this is about angular momentum, and I need many volunteers. There will be some fun, some playing around. Okay. आइए, what is angular momentum? Is I omega. I is the moment of inertia, omega is the angular frequency, right? And angular momentum remains unchanged if there is no external torque. If there is no external torque, right, if I decrease I, omega should go up. If I increase I, omega should go down. Let's just do that. लाओ भाई, आइए, कौन खड़े होंगे इस पर? आइए, आप आइए, आप इसको पकड़िए, मैं बताता हूँ ना धीरे धीरे, एक ही बार में थोड़ी बताता हूँ. खड़े होइए इस पर, इसको पकड़िए, हाथ फैला दीजिए, ठीक है, फैलाइए, अच्छे से फैलाइए. एंड उसके बाद जैसे ही मैं आपसे बोलूँगा अंदर ले आइएगा उसको, ठीक है? अभी नहीं, अभी मैं आपको रोटेशन दूंगा एंड अंदर ले आइए. That's conservation of angular momentum. Okay, फिर से खड़े होइए, जाइए. Visibly you see it, right? Anybody else wants to try it and see it for themselves? एक जो प्रॉब्लम होती है, अभी मैं इसको कर दे रहा हूँ, उसके बाद बताऊंगा आपको फिर से कि हाँ, आइए, थोड़ा नहीं, बिल्कुल ही धीरे कर देंगे. आइए, तो इसमें तो तेज घुमाना पड़ेगा ना इनको। ओमेगा आई, ठीक है। एनीबॉडी एल्स वुड लाइक टू डू इट? आई हैव मेनी मोर, सो आप कैसे बाहर जाएंगे, अंदर से बाहर आएंगे? हाँ, इसमें आपको तेज कर देते हैं फिर। ठीक है। Anybody else whoever wants to try it? I'll bring something else after this. आप तो एक्सरसाइज कर रहे हो जिम जैसे। So now the thing is, this is again a very easy demonstration to do it in the class. दो ईंटें ले आइए, रिवॉल्विंग चेयर ले आइए, उसमें बिठा कर लीजिए, हो जाता है, राइट? चेयर पे बिठा कर हो जाएगा। Now more important, what I want to show you is what I want to show you is a lot of students have difficulty in appreciating that angular momentum is a vector quantity, right? Therefore, if I just change the direction of angular momentum, I have changed the angular momentum, right? So we can demonstrate this. I need volunteers. एक खड़े होइए। नहीं, आपका रेपुटेशन गड़बड़ हो गया उससे। इसको बहुत तेजी से घुमाइए, ठीक है? और घुमा सकते हैं, जितना तेजी से घुमा सकते हैं घुमाइए, ठीक है? पकड़िए उसको। हाँ, नहीं अब रुक जाइए, नहीं उसको पकड़े रहिए, उसको घुमा के पकड़े रहिए। हाँ, आप उसको नीचे से पकड़िए ना, दोनों हाथों से मैं कुछ कर। अब इसको उल्टा कर दीजिए, फिर सीधा कर दीजिए, रुक गए। Now see, you have to interpret it. The speed remains the same. All I have done is change the direction of rotation, and he started moving. Because the net angular momentum must remain the same, right? So you have shown that it is actually a vector quantity. The moment I change the direction, I had to move opposite. उसके अपोजिट है। अब आपने अपोजिट की बात करी तो आप भी आइए, दिखाइए वाकई अपोजिट में होता है। You have to show it. हाँ, तो आप ऐसे घुमाएंगे, और तो इसका जैसे राइट हैंड से हम कहते हैं कि ऐसे घुमा रहे हैं तो ऊपर को है, नीचे कर दिया तो चेंज कितना हुआ? दिस माइनस दिस, राइट? नीचे को हो गया, तो आपको उल्टा घूमना चाहिए उसका। वो आप दिखाइए और डेमोन्स्ट्रेट करिए, तो स्टूडेंट्स को एकदम वेक्टर नेचर क्लियर हो जाता है।
I'm going to rotate this.
Whichever way you like.
Okay.
You will rotate in the opposite direction. अरे ऐसे करके ऐसे, हाँ, इसमें घुमा कर दिया और तेजी से हो जाता है। हाँ, ठीक है। अब पलटिए opposite, so that the whole thing remains constant. Okay, so this immediately tells them it's a vector. You have kept the magnitude the same, but direction change makes you rotate. ठीक है? अब रुकिए, अभी रुकिए, अब नहीं खड़े रहिए यहाँ। अब आप एक काम करिए, ठीक है? अब मैं आपको छोड़ रहा हूं, अब घुमाइए आप उसको। ये देखिए, ये भी घूमने लग गया उसको घुमाते। कंजर्वेशन ऑफ एंगुलर मोमेंटम। ओके, अब रुक जाइए। हाँ, इधर आ जाइए। आप यार सूरज वाला जैसे लग रहे हो मेरे को, कांग्रेस के स्पोर्ट्स में। अब इसको उल्टा घुमाइए, देन यू शुड गो द अदर वे, राइट? उल्टा हो जाएगा, ठीक है? Now so you see, it's all a lot of fun also, students enjoy it, but I'll make a technologically important point now. Okay, imagine you are a helicopter and you started your top rotor. करिए, चलिए। अगर आप हेलीकॉप्टर हैं और टॉप रोटर स्टार्ट करते ही आपको क्या हुआ? आप घूमने लग गए। गड़बड़ हो गई नहीं? प्रॉब्लम है। व्हाट इज द सॉल्यूशन? So let me show. आ जाइए. Here you go, right? Now you see, and therefore each helicopter has that tail rotor. Okay? The moment you start the tail rotor to oppose that rotation. Okay? You have made a technologically important point. आप छोटी सी आई ओमेगा पढ़ाया आपने, उसके बाद आपने बता दिया इंजीनियरिंग सोल्यूशन क्या धड़ से एक मिलिट्री हेलीकॉप्टर विच इज वन ऑफ द मोस्ट एडवांस वंस. ओके? और देयर इज अनदर सोल्यूशन. अरे यार, you could put two rotors in opposite direction, then this will not happen. इसीलिए मैंने आपको कहा कि आप मान लो हेलीकॉप्टर हो तो क्या होगा आपको, फिर आप बोलोगे यहाँ पे भी लगा दो यार एक, या दो पकड़ो opposite direction में. Is the point made? Right? So if you teach a core course, it's up to you how you excite these students, how you tell them what I am teaching. क्योंकि बच्चे जो आते हैं ना students, they are not exposed to things. They have not seen a helicopter. They have not seen anything, right? It is your duty to make them see things and tell them how it is, how what I am telling you or how what is being taught in the class is relevant to what you are going to do in the future.
So these examples are actually relevant for mechanics. I mean teaching mechanics.
Applied mechanics.
आपको इलेक्ट्रोमैग्नेटिक का भी तो दिया था मैंने, राइट? तो फिजिक्स 1 का ही कोर्स में कर दो, उसको आपको अप्लाइड मैकेनिक्स कोर्स तक आते आते उसका इंटरेस्ट बढ़ जाएगा. जब आप एडवांस रोटेशनल डायनामिक्स करोगे ना, वो कहेगा यार आई हैव समथिंग टू लर्न, इट इज वेरी रेलेवेंट टू माय थिंग्स, राइट? एनी अदर कमेंट और क्वेश्चन? ओके, सो दैट वाज दैट. नाउ लेट मी शो यू समथिंग मोर. आई नीड दैट. एक और एग्जांपल करूंगा, उसके बाद फिर छुट्टी. अच्छा, इसी में एक हाँ इसको हटा दो. Gyroscopic motion के लिए, and this is also easily available, and that is a ये 600-700 रुपये का मिल जाता है इंटरनेट पे, जायरोस्कोप है. ओके, एंड नाउ व्हाट यू शो टू द स्टूडेंट्स is what a gyroscope can do, right? And what you see, if I have this, इसको फोकस करके वहां पे डाल सकते हो क्या पर्दे पे? नहीं आएगा. Anyway, I can show it to them. So ये अगर चल नहीं रहा है ऐसे गिर जाता है, ठीक है? Now I'll give it a motion. ये मोटराइज नहीं है, हाथ से चलाएंगे इसको. मोटराइज तो रॉकेट वाटर में होता है. You see, earlier I made a point about stock of knowledge and flow of knowledge. I am actually using flow of knowledge, right? There is a lot available. Oh yeah, okay. So what I am going to do is now turn it and then put it on this. And everybody saw that it was falling down, right? I am going to give it a speed and you will see it stays there. Okay? So this is called a gyroscope. What it does is, it does not fall because of the rotation, right? And also you can show, if you put it in a what is called a gimbal, it maintains a direction, right? And therefore it becomes technologically very important. This was first used in V2 rockets, Germany made in World War II, to stabilize the motion of a rocket. This, because it maintains a direction, right? So if the rocket body moves, I put it in a rocket, if rocket body moves, the angle changes. You put a feedback mechanism, because that direction is maintained, that you have deviated from the path, and boom, you correct it. You go this way, again the direction, so you get a reference direction. Now electronic, a lot of your mobiles also have a gyroscope, right? You can check that. But I want to show you, let me see if I have it. This is historically very important. How a gyroscope, so this is a video that shows how gyroscopes were used initially in V2 rockets to stabilize the motion. Okay. So, again you teach this, people say why are you teaching rotational dynamics, and you make a point. Okay. And if you want to make it more relevant to Indian scenario, developing gyroscopes for our Agni and V2 rockets and the PSLV and all that was a big deal. This was not given to us by US. So, it was developed in house. It's a big deal. All right. So, yeah, slow है अभी नहीं आ रहा, ठीक है. So that's the gyroscope thing. Anyway, I mean, and this is again, you order it on Amazon, 700-800 का मिल जाता है, but it lasts for a long time. Now what I want to show you is, so I have shown you something in electromagnetic theory, I have shown you something in mechanics, I want to show you in condensed matter, the soft matter physics. Okay, again how relevant it becomes for चलने दो उसको थोड़ा सा.
Of the methods used to stabilize a rocket in flight and keep it on its trajectory, there's one that most people I think are familiar with, and that's the stick on a bottle rocket like this. The stick actually does rather more than merely hold the rocket upright in the bottle or the ramp or the tube that you're firing it from. It actually employs an active principle as a counterbalance weight, actually holding the rocket in a position, balancing the forces of the thrusting head here. We've got a solid fuel.
So you see, he's making a point that stick that we put in Diwali rocket is very important to stabilizing it, and he'll show it to you. उँगली में लगा उतारेगा. You see that how that stick helps in balancing it. Same thing, yeah. You see, that's the feedback mechanism, because gyroscope, it remains upright even though it's not moving, because there's a feedback mechanism.
These gyroscopes are the brains of the rocket. They are a universal mounting. Electrical pickups measure the movements of the gyroscope and translate these movements to the carbon vanes and the trimmers in the tail unit. These vanes and trimmers direct the rocket both in bearing and elevation
So that's how the feedback just straightens it out.
This gyroscope controls the elevation of the rocket by moving a pair of the carbon vanes, thus turning the rocket from a vertical over to an angle of 43 degrees. The other gyroscope controls the direction of the rocket by the movement of this pair of vanes.
Let's take a closer look then at a real gyro platform from a rocket. Here's one from the German V2 ballistic missile. It's fairly well laid out here. One of the great things about looking at the V2 is we get this very basic, very simple design of the gyro platform. Really lets us see what's going on. We've got two gyroscopes side by side here with their axes at 90 degrees to one another. We can see the gimbal mount here that the gyroscope rotor is in. We see the gyroscope rotor with its casing there. Other little detail to pick up is this little stud in the centre, this little platform with a little stud on it. If we look over at this one over here, we can see a lead weight has been attached to that. Almost certainly as part of the assembly process, actually getting the gyroscope in trim and in perfect balance. We can also see there's a little stud there, and another one over here, almost certainly used for adding tiny weights to that to actually get it into balance. Another little detail I want you to notice is this assembly on the end of the gimbal here. This is actually a potentiometer. It's like a volume control of a radio, and this is actually used to determine the position of the gimbal when it's in motion. So let's try to get an understanding of the properties.
You see how many engineers came together. There's an electrometer, there's a feedback, there's a mechanical engineer.
To do that, we're actually going to look at a rather popular toy.
This is the one that I have.
Gyroscope is still a popular toy, maybe in the age we're in now, maybe this kind of simple
So you can check this and
popular as it used to be. But my brother had one of these, and they
so I hope I have made the point that a core class you actually used as a propeller to students to take advanced courses, and therefore it is very important that you keep connecting with relevant information. I have about 5-6 more, but I'll stop here because I'm supposed to stop at 11. Okay. So I made points about electromagnetism and mechanics. I would have shown you soft matter, but that's some other time. Okay. Any questions, comments are welcome.
Not directly related with this topic, but can you also draw the dotted line on the blackboard like sir, with the water limits?
Huh?
Can you also draw the dotted lines on the blackboard like sir, Professor water limits?
What is that dotted line?
Professor water limits के lecture देखे थे मैंने
हाँ.
MIT पे, he also teaches physics like this only. But I interested in the style है, board पे dotted line बनाने का.
चलिए तो ठीक है. So we stop here. Okay.